So we've heard a lot about water quantity in the Western United States, or the lack thereof, and we want to focus now on water quality issues that are unique to the arid and semi-arid Western United States. Stream flow and water quality are very closely related, especially as water supply is limited. If pollutants increase, water quality decrease. So especially in low flow conditions or in small streams, the water quality issues is of higher significance. For example, leakage from mines might kill species in close proximity, but further downstream, the pollution might be diluted in a way that the concentrations are low, that they are of lesser concern. But before I discuss specific water quality issues, I want to take a step back, but I'm not going to step in this river here. I want to talk a little bit about how water quality is regulated at the federal level. So there are different water quality criteria or categories that are agriculture, recreation, aquatic species, and of course, domestic drinking water. All of these have different water quality standards as defined in the Clean Water Act, or more precisely, the Federal Water Pollution Control Act. And these regulations are then adopted at the state level as water quality standards. So we always have to keep the use in mind when we talk about water quality. For example, for recreation, look at the fishermen here behind me. Their water quality is different than drinking water quality standards. Surface water of acceptable quality is precious across the Western US. But since water quantity and water quality are so closely intertwined, I want to review stream flow, the quantity, first before we talk about water quality problems. Stream flow of rivers in the West differs strongly from that in humid regions. The bulk of the precipitation falls in the mountain ranges like the Rocky Mountains or the Sierra Nevada mountains and is stored there as a snowpack until the melting season. Stream flow is dominated by snowmelt from the mountain ranges with peak flows in the late spring or early summer. This snowmelt-dominated stream flow pattern results in low flows in the late summer, which is when many of these water quality issues are exacerbated. The seasonal cycle of meltwater-dominated hydrology is augmented by rainfall and flash floods across the West. Summer thunderstorms and monsoonal rainfalls create irregular and very strong runoff patterns, especially in ephemeral or intermittent streams across the Western US. So let's keep the stream flow in mind as we are talking about water quality. Salinity is a very significant problem across the West, and especially in the Colorado River basin or watershed. Salinity, in short, is the concentration of dissolved salts or solids in the water. And there are a number of different sources that can bring these dissolved salts into the water and into the stream. The majority of salts is leached from saline soils or geological formation like the Mancos Shale Formation, which is a marine deposit. Or it stems from return flows from irrigation in agricultural fields. Deep percolation of irrigation water leaches salts into the water and increases the salinity of return flows. Evaporation of irrigation water further increases salinity of the runoff. But it's not just salinity that's a problem in these return flows, it's also pesticides and agri-chemicals that are transported through these return flows from irrigated fields. Salinity concentrations of the upper Colorado River are about 50 milligrams per liter, but they increase to over 900 milligrams per liter at the border of the US and Mexico. These high concentrations make the water non-usable for human consumption. In fact, water is not drinkable with concentrations that have more than 500 milligrams per liter. And to put that a little bit in perspective, ocean water, very salty water, has about concentrations of 1,000 milligrams per liter. Water with high salinity concentrations is harmful for crops and extremely corrosive to pipes, damaging water infrastructure. Another big water quality issue in the West is sediment load. As you've heard in previous lectures, over the last two centuries, these rivers have undergone substantial changes in their hydrology and thus in their sediment load. Suspended sediments in rivers are silt, sand, and small gravel pieces that all make the water look muddy. because sediment is really transported with high flows, but then it is deposited when the stream flow speed is reduced. Even though mountainous tributaries contribute the majority of the flow to the perennial rivers downstream, the majority of sediment load is provided to the ephemeral streams further downstream, where scarce vegetation and heavy rainfall events cause erosion and transport bedrocks and soil into the rivers. Prior to the regulations of flow, the rivers in the West were warm, muddy rivers that had really thick sediment banks along the river, supporting an aquatic and riparian habitat where species were adjusted to these conditions, including vegetation on these banks. When rivers are dammed and reservoirs are created, the sediments that used to flow along with the relatively fast-moving rivers are instead deposited in the reservoirs. As a result of the dams, the sediment load of the rivers has significantly decreased, and the sediment settles in the reservoir, decreasing their capacity. In addition, the dams regulate the flow and change the hydrograph over the year. The smaller seasonal flow have less sediment to carry. So the reservoirs behind the dams are slowly filling up with sediment, and the water that's released from these reservoirs, it's colder, it's more clear, and it's poor in nutrients. This change in water quality, temperature, and flow regime has really put some of the native species close to extinction and is fostering the spreading of non-native species like the rainbow trout. Experimental flows along the Colorado River are conducted to attempt rebuilding of these ecosystems. And we'll hear more about experimental flows in a later lecture. Another example for water quality concerns in the West is acid mine drainage. The West is strewn with abandoned hard rock mines. Outflow and leakage from these mines cause local water quality issues. For example, the Upper Snake River in Colorado contains so many contaminants from acid mine drainage that it cannot sustain a fish population. And since recreational fishing is very popular in the area, the rivers are being stocked every 2 weeks with new fish to sustain this recreational component. Further downstream, where the leached contaminants have been decreased by dilution, the pollution can still cause issues for drinking water quality and water treatment. Organic loadings of streams, such as dissolved organic carbons, are another water quality issue, especially where concentrations are high. Dissolved organic carbons stem from decaying leaves and needles and are washed into the stream. When the water is treated with chlorine to deactivate pathogens, the chlorine can react with the dissolved organic carbons and create carcinogenic disinfectant byproducts that are a concern for human health. High concentrations of dissolved organic carbons can therefore cause water treatment facilities to shut down. And with higher temperatures under a changing climate and lower flow conditions, these problems can even be exacerbated. So in summary, as we've heard, there are many natural causes for water quality issues across the West: bedrock and soil composition, low flow conditions, low water availability, but also wildfire occurrences. However, anthropogenic changes have caused existing problems or created new problems through mining activity, damming of rivers, agriculture, or the very strong water demands of different users, including ecological demands. So regulation of water use and reuse, contamination and treatment at a watershed level will have to work together to ensure sufficient water supply for all users, including the environment, but not just sufficient supply, but also at an acceptable quality. In the rest of this module, you'll hear a few more lectures of specific examples of water quality. I'll see you next time.